In this video, we're covering USACO's 2021 February contest, the bronze level. Problem number 2, comfortable cows. Farmer John's pasture can be regarded as a large 2D grid of square cells. Picture a huge chessboard, all right? Initially, the pasture is empty. Farmer John will add n, which is somewhere between 1 and 10 to the 5th cows, to the pasture one by one. The ith cow will occupy cell xi, yi. Okay, so what that's saying is we've got some number of cows, n cows. So for example, if n was 5, that means we have 5 cows. 1, 2, 3, 4, 5. Each of these cows is going to occupy a cell location. For example, the cow at cell 3 could be at 7, 4. And that would represent the x and y location of cow 3. So when they're talking about xi, yi, what they're saying then is in the case of I equals 3, which is the 3rd cow, the x position is called xi, so x3 in this case would be 7, and y3 in this case would be 4, 7 and 4. So the ith cow occupies a cell xi, yi that is distinct from the cells occupied by all other cows. And then it also says that xi and yi are both between 0 and 1,000, which means, and including 1,000, which means we've got a grid where the top level is going to be 0. The bottom level is going to be 1,000. Now, something to watch out for. This means that there's actually 1,001 of them. If I've got my top as 0 and my bottom is 1,000, then 0, including 0 and 1 and 2 and 3. If we count the 0, we have one more than 1,000. A cow is said to be comfortable if it is horizontally or vertically adjacent to exactly 3 other cows. So horizontally or vertically adjacent, what that is meaning is if I've got like a tic-tac-toe board shape here, if I have a cow in the center, that cow is only going to be comfortable if it has exactly 3 horizontal or vertical neighbors. So for example, 1, 2, and 3. And that means that cow is comfortable. Now, any cows that are diagonal to it don't affect this. So it can be completely surrounded in cows diagonally, but still be considered comfortable, provided it has horizontally and vertically exactly 1 empty space and exactly 3 cows otherwise. For each eye in the, let me see, comfortable. Farmer John is interested in counting the comfortable cows in his farm. For each eye in the range of 1 to n, output the total number of comfortable cows after the ith cow is added to the pasture. Okay, so what they're saying then is, remember before we had our cows numbered 1, 2, 3, and so forth. As we place these cows, every time we place a cow, for every I in the range 1 through n, so like for example 1, after placing cow 1, we want to know how many comfortable cows there are in the entire pasture right after placing 1, and then right after placing 2, and then right after placing 3, which means we probably are going to want to keep track of how many cows are comfortable at any given time. We'll talk about the limitations on the input here in a second and see why that's the case. Input format. Input arrives from the terminal, so just typed into the console. The first line contains a single integer n, that's n. Each of the next n lines contain 2 space-separated integers, indicating the x and y coordinates of a cow's cell. So that's a cow, that's a cow, that's a cow. It is guaranteed that these cells are distinct. Because of the fact we're going to be solving this with an array, despite the fact they keep calling this x, y, we actually could treat this as row column. For me, that makes it a much easier thing for me to read and understand. I'm just less comfortable converting from, because if you use x, y, for example, and then we have like x going in the positive direction this way and y going in the positive direction that way, then we're still going to have to flip that around to convert it into an array, which usually is represented as top down with row 0 being at the top. We call that row major, 1, 2. Since rows and columns are easy to work with, it's not actually going to affect anything. So I'm going to be treating this first one like the row number and the second one like the column number. And this won't have any impact on the answer. It just, for me, it makes it easier to work with, and it's probably going to make it easier to code. Okay, output format, also just printed to the terminal. The ith line of output should contain the total number of comfortable cows after the first I cows are added to the pasture. Basically just, yeah, it's saying we're going to add them one by one, and then we need to know how many comfortable cows there are. So let me see if I can freehand draw a grid here. I got to go up to 4. I'm going to go 0, 1, 2, 3, 4. Did I do that right? 0, 1, 2, 3, 4. 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, so as we add these cows, we want to try to keep track of how many comfortable cows there are on the field. And the reason why is I was mentioning complexity earlier. We have, let me scroll up and write these numbers down. We have up to 10 to the 5th cows. That's 100,000 cows. In addition, the pasture is 1,000 by 1,000 by 1,000. So let's think about what that means in terms of how difficult this problem is going to be to solve from the standpoint of the computer. I wrote this in a bad location. 100,000 cows and 1,000 by 1,000 grid. Okay, so just try to imagine if I wasn't keeping track of how many comfortable cows there were, and I'm adding cows, and I add a cow here. What I essentially need to do then is go through each one of these cells one by one, what I would need to do if I didn't have a running total, and check each one of these up, down, left, and right to see whether or not it's comfortable. The reason why that's a problem is if you do a little bit of math, you figure, okay, for every cow I place, which is going to be 100,000 cows, I'm going to have to go through an entire field that's 1,000 by 1,000. So that's times 1,000 times 1,000. And then for each one of those, I have to check up, down, left, right, which is times 4. If I multiply all these together, I'm going to get 4, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, which is that 400 billion? 400 billion. So I've got 4 times 10 to the 9, 10, 11. 4 times 10 to the 11th. Now, for the most part, for most of these problems, if you get up to 4 to the 10th, you've gone too far. 4 to the 9th is about your upper limit to be able to solve these problems. 48th usually is comfortably solving them, but 4 to the 11th is going to be out of range. So we cannot afford to place a cow and scan the entire field, and then place a cow and scan the entire field again and do that for every cow we place. We have to find a more efficient system. So what that means is that every time we place a cow, we need to make an observation on what could have changed and what can't have changed. If I place a cow in this location right here, then the potential candidates that are going to change are only going to be its immediate neighbors, because it's possible that one of them has become comfortable as a result. For example, if I already had a cow here and here and here, then upon placing the red cow in the middle, the cow right above it, this cow here, will suddenly now have 3 neighbors, and she will become comfortable. However, if I had a cow here like that, then even though this one right here has 3 neighbors, if I don't have a cow there, then even though I've placed one here, this doesn't suddenly become a comfortable cow, even though it has the 3 neighbors, because there's no cow there, so there's nothing to be comfortable. But those changes and those rules are only going to impact the cows immediately surrounding this cow right here. So the immediate neighbors may have become comfortable, and likewise, this newly placed cow itself might be comfortable. For example, if I already had cows here and here when I placed the red cow, then the red cow would have been dropped into an empty location that already had 3 neighbors and would immediately become comfortable as a result. Likewise, placing a cow could cause a cow to become uncomfortable. So if my cows were in these locations and I'm placing a new cow in this location right here, then even though that cow is going to be comfortable, it's going to cause the cow next to it to become uncomfortable, because that was the one empty space next to that cow, and now that cow is fully surrounded. So let's run through a sample here and see what we can do as far as keeping track of which cows are comfortable and which cows aren't. Ultimately, what we're going to need to do for each square is we're going to need a count of how many cows there are, along with whether or not there even is a cow in that location. I'm going to represent that by making a dot if there's a cow. So if I put a dot in the corner, that means there's a cow. And then on the other corner, I'm going to put a count for how many neighbors they have. So for example, 0 neighbors, 1 neighbor, and so forth. And once we start going, this will make more sense. So, okay, 0, 1. So I'm just going to use, remember, I'm not going to use X, Y, I'm going to use row 0, column 1. So for 0, 1, I have row 0, column 1. Let me see if I can move this down a little bit. There we go. Okay, for row 0, column 1, I'm going to put a cow here. I'll represent that with a dot. And that means now I have a neighbor here, 1 neighbor here, 1 neighbor here, 1 neighbor here. 0, 0 has a neighbor, 0, 2 has a neighbor, 1, 1 has a neighbor. Those ones where I change the number of neighbors are the only ones I need to check to see whether or not they've become comfortable. And I don't actually even need to look at their neighbors to know that. I just need to know how many neighbors they have. In this case, they all have one neighbor. So none of them are comfortable. My counter of how many comfortable cows I have is 0, and it remains 0. So I print 0, and then I can move on to the next cow. 1, 0, row 1, column 0. I'm going to put a cow here. And then this now is going to become 2 neighbors up above. That's a 2. This is going to have 2 neighbors to my right, 2, and then down below now this is 1 neighbor. Let's just double check that. So this has 2 because it's got 2 neighbors. This has 2 because it's got 2 neighbors. This has 1 neighbor. This has 1 neighbor, and our cows are here and here. Looks good so far. Next is at 1, 1. So I'll put a cow here. That cow already has 2 neighbors, but that's not enough to make it comfortable. So my counter is still 0. Just make sure I'm printing these out as I go. So place this cow here. This one, which has a cow, now has 1 neighbor. This now has 1 neighbor. This has 1 neighbor. And then this has 1 neighbor. Still 0 comfortable cows. Next cow is at 1, 2, row 1, column 2. That's going to be over here. Now at this point, I've created my first comfortable cow. That is, this cow right here has just become comfortable. The way I'm going to know that is as I'm going through from this, upgrading the number of neighbors. The neighbor to the north now has 2 neighbors. The neighbor to the east has 1 neighbor. The neighbor to the south has 1 neighbor. The neighbor to the west now has 3 neighbors. Anytime a number becomes a 3 as a result of placing a cow, we have to add 1 to our counter because that means we've created a comfortable cow. That also goes for any time we place a cow in a location that already had 3 neighbors. That also would cause adding a cow. And then the inverse is the case for 4. If we create a 4, then we've lost a comfortable cow. So that's that 1 right there. We now have 1 comfortable cow on our grid here. 2, 1. Go to column 1. We're going to place a cow here. Updating the number of neighbors. South neighbor now has 1 neighbor, despite the fact there's no cow. East and west now each have 2 neighbors. 2 and 2. My north neighbor now has gone from 3 to 4. Whenever we have a 4th neighbor, that means that we are no longer comfortable. I'm going to color this one, I'm going to black this one out. That's no longer comfortable, which means I got to do -1 here, which is now back to 0. And that's that 0 that I outputted down here. All right, 2, 2. Row 2, column 2. We're going to put a cow here. I now have 1 neighbor to the south, 1 neighbor to the east, and now 2 to the north and the west. 2 and 2. Number of comfortable cows did not change, so I still have 0, and that's that 0 right there. I have a cow at 3, 1, row 3, column 1. That's here. So now I have 1 to the west, 1 to the south. This is going to go up to 2. And now this one's going to become a 3 to the north. I'm going to color that one green because it just became 3. So that's going to be a +1 equals 1 comfortable cow now. And that's that 1 right there. And then finally, my last cow at 3, 2, or 3, column 2 goes here. It's going to be 1 to the south, 1 to the east. West goes up to 2, which, by the way, just to point out again, changing the number of neighbors here can't have any impact on its neighbors. So this will not cascade. We do not have to be able to search through the map. We only look at our immediate neighbors. And then 1 more now to the north, 3, which is going to change that to a comfortable cow, which also, again, has no impact on this cow because just because this one became comfortable doesn't mean that one's changing. So again, just reinforcing that this is not going to cascade. We only have to look at the immediate neighbors. So +1 equals 2, and then that's that last 2 output right there. So essentially what you're looking to do is to create some sort of a 2D structure, possibly with tuples, possibly with a pair, possibly with a custom data structure, or have 2 completely separate structures. Maybe you have a 2D array of integers to keep track of the neighbors and a 2D array of Booleans to keep track of true, false, whether or not a cow's in a particular location. There are in fact a lot of ways to approach this, but basically what you need to be able to do is given any row and column, we need to be able to, in immediate constant time, know whether or not there is a cow there. Because if we're placing a cow there, we have to be able to change it to true. We also then have to be able to look up, down, left, and right to see to add 1 neighbor, to add 1 to all the neighbors of our north, south, east, and west neighbors. But then also to check to see if any of those became a 3 as a result, which would mean adding 1 to the count. or has become a 4 as a result, which would mean subtracting 1 as a count. You also have to take special care, and I mentioned this earlier, take special care when you're placing the cow. If you're placing a cow into a location that already has 3 neighbors, even though the number of neighbors at that location didn't change, because we're placing a cow in the square, which doesn't affect its neighbors at all. Even though the number of neighbors didn't change, if it already had 3 neighbors, we need to mark that as a comfortable cow. But if it already had 4 neighbors, we don't need to subtract 1 from the counter because there never was a comfortable cow there. And let me just kind of draw that out real quick. So to sort of visualize that, if I have, I'm gonna use that tic-tac-toe grid. If I have a cow here, here, and here, and I'm about to place a cow in the middle, because this already has 3 neighbors, then when I place the cow here, that's +1 to the number of comfortable cows. However, if I had 4 cows here, then I were to place a cow here, even though this has 4 neighbors, that is not subtracting a comfortable cow because there was never a comfortable cow there to start with. So the order that you do these in is important. However, if I have 3 neighbors, and then I place a cow here, that's going to be +1 to your number of comfortable cows. But then if I were to place 1 here, then that becomes -1 because this is affecting the neighbor. I'm trying to think if there's anything else you need to know for this. So essentially, yeah, so essentially what you're going to do is you're going to keep track of, as you're loading the file, you probably don't need to load the cows into any structure. You probably can just do it as you're reading the file. As you read these numbers out, update true or false, whether or not any given location has a cow. Check to see whether or not that cow is comfortable. Update the neighbors to see whether or not they have, how many neighbors they now have. And if any of them have a cow and have become 3, we need to mark them as comfortable. If any of them have a cow and become 4, we have to mark them as uncomfortable. One last thing regarding these numbers, you do have to be careful about checking, since you're going north, south, east, west, when you place one on the top row, we do need to be careful not to go out of bounds here. If we go out of bounds and check up or left off of the top of the grid, then we're going to crash the program. So one of the things you can do is add a buffer around the outside. Now, because the grid is 1,000 by 1,000, it's not actually 1,000 by 1,000. It's from 0 up to 1,000, which means it's actually 1,001 by 1,001. So if you want to add a buffer around the outside, you're going to need 1,003 by 1,003 to be the size of your array. So when you create your array, if you create it with 1,003 rows and then 1,003 columns, and then every time you load up these numbers, just add 1 to your row and add 1 to your column. Anyway, good luck coding it, and I'll talk to you in the next video.